When I started to learn the C programming language, I used to malloc in this fashion. For the sake of argument, let's say that I need a double pointer in the heap. So I would do something like this, malloc, giving as an input the size of a double, of course. And then I would cast the return of the malloc to the actual type of the variable, which is a pointer to a double, like that. I will then put this value at f. Then I'm gonna print the actual value of the pointer and the pointed value, which is this one. Then we are gonna simply free as good citizens in C. If I run the code, everything works properly. Here we have the pointer address and here the value pointed. Now with time I understood that this is not probably the best way to malloc in C. Let me explain with some pros and cons. So first thing is that under the C standard the cast is simply redundant. Indeed, the code works exactly the same. If I remove the cast and I run, nothing really changes. Because the void pointer returned me by the malloc is implicitly promoted to a pointer to a double. So in C, we don't really need the cast. One positive thing of casting is that this code is also valid C++ code. Indeed, if I compile for C++, you see that the code works exactly the same. This is not the case if I remove the actual cast. Compile for C++, and you see that I get a mistake this time. Indeed, in C++, you have to make an explicit cast. So having this cast is good if you want to have code portable to C++. Another good point is that it forces an extra cognitive cross-check. Basically, this explicit cast is like an assert, right? Every time I have the compiler that is checking that this type is equal to this type. Basically, here, if I remove this cast and I wrongly malloc a size of a float at this point, the compiler is not saving me, right? On the contrary, here, if I put a pointer to a float, making myself as a programmer this cognitive cross-check, right? I can see with my eyes what is going on. Well, I have the compiler that is yelling at me. It's telling me incompatible pointer types initialization, double star with an expression of type float star. So at times redundancy can be beneficial for this purpose. Now for the negatives. Well, of course, the code is not dry, right? There is plenty of repetitions, double, double, double. And this of course adds clutter to your code. Being the code so verbose, it's hard to refactor. Namely, if I want to change the type of the variable, let's say here I want a float, because I don't need that much precision, I have to change also the cast and the size of operand, like that, which is kinda annoying, right? So let's analyze now the pros and cons of removing the cast. Well, the first thing is that this is not valid C++ code. It is only C code. Second point is that this code doesn't force us an extra cognitive cross-check. So here, if I put a char for unknown reasons and I compile the code, I don't get any warnings. So the compiler is not helping you with type mismatches. The actual positive things are that, okay, under C, the cast is redundant, so you just leverage the implicit conversion of void pointers to write less code. The code is drier than the previous one, even though we are still repeating the double here and here. The code is less hard to refactor. Namely, I have to change the type here and the type here. But overall, I would say that this is not a massive improvement, right? Probably casting is still better. Now let's try this one. This time I'm gonna malloc, and I'm gonna pass as an input size of, and the difference this time is gonna be at f. Here I'm telling, hey, malloc the size of the pointed thing. So you see what I'm doing here. I'm simply locking the two. Let's see the advantages of writing like that. The first thing is that I have this very cool locking of the operand of the size of and the actual type of the pointer. Namely, if I happen to change the double to a float, no problem, right? I don't have to change this. This is gonna be done automatically. We are not writing redundant C code. The code is dry, we are not repeating ourselves. Namely, I am repeating myself with the variable, but this is not a stupid repetition. This is a strategic one that is gonna lock the type of the variable and the operand of the size of. So this is not dry code. And as I showed you, it's super simple to refactor, right? I can change the type of the variable and automatically the code is refactored. The only downside is that this is not valid C++ code, right? But I strongly believe that C and C++ are two different languages. My humble opinion. Now, mallocing this way to me is very good. One last thing can be that all the time you have to check for null pointers, right? Because the malloc can fail a null pointer. In that case, you need to do something like this, right? And maybe call an exit or whatever. Well, if you have to call the malloc function many times in your code, you will be filled with assertions or controls on the return value of the malloc. One smart thing that I like to do is to create wrappers. Basically, I can do a wrapper like that. Inside, I have the actual control on the malloc return. And I will simply call the print error function and maybe the exit function or whatever you need. If everything is fine, I will simply return the pointer from the original malloc. So the last optimization I would do is to replace the original malloc with my wrapper. And there you go. The code works exactly the same as before. Here, for example, if I do malloc -1, and if I launch the code, you can see that I get malloc error. Cannot allocate memory, and we exited with 1. So this is, in my opinion, the best way to malloc